Welcome back. For today's SAT question, we have a problem that involves absolute value expressions. And the question states, which of the following expressions is equal to 0 for some value of x? So we're given 4 different possible answers to choose from. And they want to know which one of these expressions is equal to 0 for some value of x, where x would be possible. So you might think, well, that's easy enough. I'll go ahead and just set one of these expressions equal to 0. We'll just go ahead and pick a. So let's go ahead and say absolute value of x minus 1 is equal to 0. So when we have absolute value problems, what I like to do is take, whatever's inside, put parentheses, and then you're going to end up making 2 separate equations from this, from what's inside the absolute value symbols. So we'll say our first equation will be x minus 1 is equal to 0, and then our second equation will be negative x minus 1 is equal to 0. So in this case, we have x minus 2 is equal to 0, so x is equal to 2, and that's one of our solutions. And in the other equation, we have negative x plus 1 after we distribute, minus 1 equals 0. These cross off, and then you have negative x equals 0, so x is equal to 0. So these are our 2 possible solutions. Because it's an absolute value equation, we need to check to see if they're extraneous solutions. So let's go ahead and plug both of these solutions, possible solutions, back into the original equation here. So we have absolute value of x minus 1, but we will now substitute in the 2, so we get 2 minus 1 equals 0. And then 2 minus 1 is equal to 1, and 1 minus 1 equals 0, and so 0 equals 0. So that works. So now we try the other possible solution, x equals 0. We plug that into this original equation here. We have 0 minus 1 equals 0. And so we have negative 1 absolute value, but that's just positive 1 minus 1 equals 0. So we also get 0, and 0 equals 0, check. So both of these solutions work. So chances are the answer is going to be answer A, which it is. And so what you can do to double check to make sure that you didn't make any arithmetic errors, we can just look at this other question B, or this other possible answer B, and do the same thing. So if we had the absolute value of x plus 1, and we set that equal to 0, we do the same thing. We say whatever's inside the absolute value symbols, we put parentheses around there, and one will be positive, one will be negative. So this guy will be positive. So we'll say x plus 1 equals 0. And in this case, x is going to be equal to negative 2. And for our second one, we're going to have negative x plus 1 equals 0. So this, when we distribute this through, we get negative x minus 1 plus 1 equals 0. These cross off, and you have negative x equals 0, so x is just equal to 0. So when we put in this first possible solution here, so we put in x equal negative 2 back into the original equation, you'd have the absolute value of negative 2 plus 1 equals 0. And this left side should equal 0 if this is a solution. So you'd have negative 2 plus 1, that ends up being negative 1, but that's the absolute value, plus 1 equals 0. And then you get 1 plus 1, which is 2, so you get 2 equals 0. And that doesn't make any sense, question mark, so that is wrong. So we know that this guy is an extraneous solution. X equals negative 2 does not work. So then we try the second solution here, possible solution, and we say absolute value of 0 plus 1 equals 0. Absolute value of 1 is just 1. 1 plus 1 is 2. So then same thing, you get 2 is equal to 0. That makes no sense, which means this is also an extraneous solution. And if we were to do that with C and D, you would see the same thing, that you would get extraneous solutions every time you try checking your solved algebraic solution. And the only one where you get non-extraneous solutions is answer A.